Alright, after a short break, let's check the examples in 5.2 volumes. Example 1 shows that the volume of a sphere of a radius is V equals 4 over 3 pi r cubed. Actually, that is the formula of a solid sphere, right? Solid sphere. Then we are going to show the volume. Why it's this formula? And let's place a sphere. Okay, let's place a sphere in this way. So let's check we place a sphere in the XOY plane from minus R to R, okay? And with the center, with the centroid of the sphere at the origin point 0, 0. And we know it's in the 3-dimension, okay? It's in the 3-dimension. And with the radius is r, okay? With the radius is r. Then let's check that to find the volume, to evaluate the volume. Let's repeat the definition, okay? Let's repeat the definition. Definition of the volume. That will be V equals the definite integral from a to b ax dx. Now here, if we place the sphere in this way, then the lower and upper limit will be minus r to r. No problem, right? Minus r to r. Now we need to figure out the area function, right? The cross section area function ax, right? Ax. Now at some point, okay, at some point x, you can choose your x either on the negative part or positive part at the position x, and we know this x is between minus r to r, right? At the point x, let's check the graph. Sorry. At the point x, and we know the x is between minus r to r, right? So at the point x, we get the cross section area, right? We get the cross section region is shown in red. So the cross section region is shown in red, in the red color. And by the way, what is the shape? Okay, what is the shape? It's showing in red color, and it's a circle, right? It's a circle. It's a circle. Actually, if you cut it at the position x, it's a circle. What is the radius? What is the radius? What is the radius of this circle? No one replied. So the radius, you will check that this is a circle. This red part is a circle. And what is the radius? The radius will be this height, right? Will be this height. What is this height? This height is y, right? This height is y. So it's a circle with the radius y. But how can you express the y using the x? We know the radius here. It forms a right triangle actually. This part is r, which is the radius of the sphere. What is here? What is this length? What is this horizontal length? This is x, right? This is x. So y form the right with the right triangle. My y will be r squared minus x squared, right? And you will notice that as the x change, the circle will be different, right? As the circle changes, the as the x changes, the circle will change. It depends on the radius, right? Depends on the radius. So that is the circle, right? That is the circle. Then the cross section area. Then the area of the cross section. Then the area of the cross section at the point x, right? At the point x is pi is a circle, right? The cross section region shown in red color is a circle, and we know the radius. So the cross section area will be pi y square, right? Pi y square, which is pi r square minus x square, right? And we know this is the cross section area at the point x, right? At the point x. So here actually we understand if we do the if we evaluate the integral, that means you take the sum of all those slab, right? You get the slab. We understand before with the to get the volume, to get the estimation of the volume of a solid sphere solid, then you can cut into several cylinders, right? With very thin height, okay, very thin the thickness. You can get several tiny cylinders. So that is the idea actually. But we only need to check the cross section area function ax here, because in the definite integral we need this cross section area. And of course this area, the area of this circle will be different, right? The area of the circle will be different. For example, at x equal to 0, at x equal to 0, so you can cut a circle looking like this one, right? You can get a cross section area. It's a circle looking like this one. That is the largest circle, right? That is the largest circle. So when x equal to 0, you can get your ax, which is ay square, right? Ay square. When x equal to 0, of course, it's pi y square. Sorry, it's pi y square. It's a circle, right? The area of the circle will be pi y square. So will be pi y square, pi y square. So that will be r square minus 0. You can get pi r square. Of course, right? Of course, this circle, when x equal to 0, this circle's area gives pi r square with the radius of the sphere. Now, as the exchange, as the x shifting, as the exchange, the area of this circle will change. This one gets smaller, right? Smaller than pi r square. So we only need to figure out the cross section area function, and we need to make sure that is the function about x. If you get it's pi y square, you should rewrite it as a function of x. Then you can evaluate the volume. Then the volume, okay, according to the definition, the volume of the sphere, okay, the volume of a sphere is, you can do volume. Oh, pi r. Oh, yes, pi r. No, it's about the square. Here should be pi y square. Let me write it in this way, okay? It's pi y square. Pi y square should be pi r square minus 0, okay? There is no problem. Pi y square, the radius is y. And especially when x equal to 0, the radius is r, so pi r squared. So the volume will be minus r to r. My area function is pi r squared minus x squared dx, and you take this integrand as a function of x. So the antiderivative will be pi r squared x, right? Pi r squared actually is a constant. The radius r is given. And then minus pi times the antiderivative x cubed over 3. And that is the antiderivative evaluated at minus r to r, right? Minus r to r. And actually this is the twice, right? This is the twice of the definite integral from 0 to r. If you notice that will be twice. It's symmetric about y-axis, okay? It's an even function, you can call, right? It's an even function. So here from minus r to r, you can write twice from 0 to r. And you can work out, finally the answer is 4 pi r cubed over 3. Then we prove that, okay? Then we prove that the volume of a sphere should be 4 pi r cubed over 3. So that is the first example. We prove that. Now let's check the second one. Find the volume of the solid obtained by rotating about the x region under the curve y equals root x from 0 to 1. So this part, okay, this part, a lot of hand drawing is required. To draw some function curve we studied before, and you need to figure out which axis they are rotating, what kind of solid we will get. So you need to draw those by yourself. So first let's check the curve y equals root x from 0 to 1. Okay, now let's check that. Figure out the function, then they will rotate it to get a solid. So this is y equals root x. Okay, y equals root x. And from 0 to 1, okay, from 0 to 1. Here is 1, x, o, y coordinate. So this function is y equals root x. Find the volume of the solid. Now this kind of solid we call the volume of rotating solid. Okay, rotating solid. You get a region first, then you rotate it. So let me use a different color. Okay, let me use a different color. Find the volume of the solid. How can we obtain the solid? So we get this region. Okay, we get this region. The curve, under the curve y equals root x from 0 to 1, which means you get this part. Okay, you get this part. How can you rotate it? Rotate this region about x-axis, so we draw a sign like this one. Okay, rotate about x-axis. If rotate about the y-axis, we do this way. Okay, we do this way. So it's about the horizontal way. You rotate this region about x-axis, so you get a solid. Okay, you get a solid looking like this one. So it's shaded in the blue and looks like a trumpet. Okay, trumpet. So looks like the solid. Okay, the solid. Like trumpet. So you need to imagine, okay? You need to imagine the solid we get by rotating the region, okay? By rotating the region. So this is the region in 2 dimensions. So if you rotate about the x-axis, which means you rotate it in a horizontal way, okay? In a horizontal way, then you get a solid, okay? You get a solid to you get a solid like a trumpet, okay, trumpet. And so from 0 to 1, actually, if you cut, this is the slab we got, okay. This one showed in the red color is the slab we got. What is the shape of the cross section? So try to check the cross section, the region of the cross section. This part will be the cross section region. Again, it's the same. We need to figure out the cross-section area function, okay? The area function AX. Of course, the cross-section region gives a circle, right? Gives a circle. If we get the ice slab, you will notice that it's a thin cylinder, okay? It's a thin cylinder. So in this way, the cross-section region gives a circle. If you can figure out the radius of this circle at the position x, then it will be easy. It will be easy to write the area function, right? So at the point, okay, at the point x, at the point x, if we know the radius, if we know the radius of the cross section region, and if we know the radius of the circle, if we know the radius of the circle, why it's a circle, that is the region of the cross section, right? That is the region of the cross section. I would call the cross-sectional region. So if we know the radius of the circle, then the area, okay, the area of the cross-section function, the area function is pi radius square. By the way here, the radius is not always x, okay? The radius is not always x. Like the previous example we did, it's y, right? It's pi y square. So actually you need to check out by yourself, okay? You need to check out by yourself. So of course here, this one gives the radius, right? This height gives the radius. So the radius actually will equals to y. The radius is y, is the height, right? What is y? This is a curve. This is bounded by the curve y equals root x. So here the radius will be root x, okay? Will be root x. This is the curve. This is a curve y equals root x. Right? This is a curve y equals root x. So the radius is y. Of course, the radius will be root x. So be careful when you talk about the area of the cross section, the area function ax. That is not always pi x squared. Okay, be careful to check that. Now let's check the solution. Repeat the question. So the region and the solid trumpet are shown. Okay, the region will be this one, which is the circle, right? Which is a circle. Now slice at the point. Okay, slice at some point. Of course, this point x will be some value between 0 and 1, right? Between 0 and 1. That is a and b, right? Between 0 and 1, that is a and b in the definite integral. So the cross section is a circle with the radius. You need to check the radius carefully, right? The radius y. What is y? Y equals root x, as we did, right? As we did before. This is y. This is the radius, which is y. Y equals root x according to the function, right? According to the function. So the area of the cross section ax will be pi y square, right? Pi y square, which is pi x. So after we figure out the area of the cross section, then that will be easy to evaluate the volume of this trumpet, right? Of this trumpet. So since the solid lies between 0 and 1, the volume should be the definite integral from 0 to 1 ax dx. Now what is my integral on ax? That is pi x. So it's pretty easy to get the definite integral of pi x from 0 to 1. You get pi x squared from 0 to 1, which is pi half, right? It's pretty easy. Okay, it's pretty easy. So the volume of this solid, how can we obtain this solid? Rotating by x-axis, right? Rotating by x-axis in this way. We marked here, okay? Rotating by axis, we marked in this way. If rotating by y-axis, we will mark here, okay? We will mark here next to the y-axis. So that is example 2. Okay, that is example 2. Any questions so far? Now let's look at one more example, okay? Let's look at one more example. Find the volume of the solid obtained by rotating the region bounded by y equals x cubed, y equals 8, and x equal to 0, rotating about the y-axis. So let me show you the region first, okay? Let me show you the region first. Then figure out, after rotating, how the solid looks like, okay? So establish the XOY axis. Y equals x cubed. This is y equals x cubed. Okay, y equals x cubed. Y equals x cubed. X equal to 0. This one is x equal to 0, right? X equal to 0. Y equals 8. Y equals 8 is this horizontal line. Y equals 8. Okay, y equals 8. So this region, y equals 8, and of course when y equals 8, the x equals 2, so it will be easy to figure out the lower and upper limit. And let me shaded the region, okay? Let me shaded the region. So will be y equals x cubed and y equals 8, this horizontal line. X equal to 0 is this vertical line, is this y-axis. So that will be the region this way, right? That will be the region this way. And then how can we rotate this region? Find the volume of the solid obtained by rotating the region about the y-axis. Rotating this region about the y-axis, I'm going to draw this rotating sign. Okay, so you will rotate this part about the y-axis. Okay, about the y-axis, you will get this one. Okay, you will get like a goblet. Okay, like a one cap, like a one cap. You can imagine how it looks like for the solid, or we call it goblet, right? Goblet. And we understand this bounded curve here, this bounded curve here will be y equals x cubed, right? This bounded curve will be y equals cube. Now this time we will use the y. Okay, we can use the y to evaluate. So if we use the y, the formula can be, for y will be c to d. You need to figure out the lower and upper limit for the y, for the variable y. Then you still figure out the cross section area for the variable y. So for the variable y, you are going to cut your cross section region in the horizontal way. That is the cross section slab. That is the slab we got. So here is the delta y. Okay, just means you rotate the slab 90 degrees. So you get it in a horizontal way. Okay, in a horizontal way. Of course, you will notice that actually again the cross section region gives a circle, right? The cross section region here. The cross-section region here is the circle again, but you need to figure out the radius of the circle. Okay, the radius of the circle. And here it's easy to check that this is the radius of the circle, right? This is the radius of the circle. Radius of the circle. What is the radius? The radius of the circle is x, right? Is x. When we cut it at some point y, what is my y? What are the values c and d? So c equals 0, right? Lower bounded by 0 and top bounded by 8. So that's why we use y as a variable to get the volume. Okay, that will be more convenient. So we figure out the cross at the point y, then the radius will be x, right? The radius will be x. So the area, the cross section area, ax will be pi x squared, right? Pi x squared. But we express it as x, so we need to change it as y. So it's pi x squared. But how can we rewrite x and y? How can we rewrite x and y? So here is x. This length is x, but this point is on the y equals x cubed. Then what is your y? So you can express in this way. You can express in this way. So let me write as y. Okay, let me write as y. Pi y squared. Sorry, it's pi x squared, right? It's still pi x squared. But what is my x? What is my x? My x will be y 1/3, right? Y 1/3 in this way, right? Y 1/3. From here, right? From here, what is your x? The x will be, you take the cubic root of y, right? So I can rewrite in this way. So the cross-section area function will be 2/3, right? So this one is we rotate about the y-axis. Okay, rotate about the y-axis, we get a solid. Now let's check the solution. Okay, let's check the solution. So the region and the solid looks like a goblet as shown. Okay, as shown like the previous one. So slice at the point y, the cross section is a circle, with the radius x, right? With the radius x. And then the area of the cross section will be pi x squared, right? Pi x squared. But pi x squared, we should express it as y. So will be, for the y will be y to the exponent 2/3, right? 2/3. So we are going to integrate this function from 0 to 8. It's about y from 0 to 8. So since the solid lies between y equals 0 and y equals 8, we use y. Okay, the volume is, so evaluate this one, right? Evaluate this one. Find the antiderivative. The antiderivative will be y to the exponent 2/3 plus 1 over 2/3 plus 1, and you get 3/5. You can keep the constant pi outside. right? You can keep the constant pi outside, then from 0 to 8. Then finally you get the answers, okay? You get the answers, 96 pi over 5. So you can review this evaluation of definite integral after class, okay? You can work out this calculation part by yourself after class. Now let's do a little summary, okay? Let's do a little summary. So for all those, you notice that the cross-section region will give a disk. It's a disk, right? So we find the radius of the disk. It might be using x or using y. So the area of the cross-section will give the function as pi radius square, right? Pi radius square. Then the volume of S can be evaluated in this way, using X, or using Y evaluated in this way, right? So important part is to find the area function of the cross section either depends on the X or depends on Y. Now let's check this quiz, okay? Let's check this quiz. So this is the model of the pyramid, okay? This is the model of the pyramid, and the base is a square, okay? The base is a square with the side length. The base is a square with side length L, okay? With side length L, big L. And the height of this pyramid is h, okay? Is h. So we are going to evaluate the volume of this pyramid, okay? With so from all those options, you will notice that we were using y, okay? We were using y. So it's obvious. It's obvious you can do the lower limit from 0 to h if you place your pyramid in this way, okay? If you place your pyramid in this way. So we were using y, so we cut for y between 0 and h, we cut it, okay? We cut it at the point y, Let me give you some hint to finish this quiz, okay? At the point y, and of course this y is between 0 and h, and this is the way we place the pyramid, okay, in a vertical direction. So the cross section region, okay, the cross sectional region is in red color, right? It's showing in the red color. The cross sectional region, what is the shape? The cross section region showing in red. And by the way, what is the showing in red? What is the shape? Showing in red. And of course it's a square, right? It's a square again. It's a small square than the base. So it's a square again. Then how can we find the area of this square? So we need the area function ay to figure out the length of the square. So the length of the square will be this one, right? This is the length of the square, will be this one. We can call it L0. Let's call it the square with the side length L0, with the side length L0. If we can figure out this L0, then we know the AY is L0 square. Of course, this is a variable about y. This will change, right? As you shifting your square, right? You shifting your square, you can form a square here. You can form a little square here, like that, right? You can form a little square here. So the side length will change. So we are going to figure out this L0. Now we are going to check this. I'm going to check this triangle. Okay, I'm going to check this triangle. Let me use a different color. Okay, let me use a different color. So we are going to look at this triangle. Okay, this is the triangle. I'm going to not this triangle, not this triangle. It will be another triangle. Sorry. Be patient, okay? Be patient. I will explain how to work out the volume of this pyramid. Give you some hint and you will figure out, okay? You will figure out by yourself to finish this quiz. Now let's looking at a triangle in this way, okay? In this way. This height is h. We know that this height is h, and this length, okay? This length will be half of the side length, which is half L, right? Half L. And since it's a right triangle, it's easy to work out this side, right? It's easy to work out this side. And L0 is the same as this part, right? L0 is the same as this part because it's a square, right? So we are going to look at the triangle in this way, okay? A triangle in this way with a right triangle, with a right triangle. This is the right triangle. This part is height h. This one is half of the side width, the side length, and then let me use more different color. Okay, now we can form a smaller triangle. Okay, we can form a smaller triangle. We can form a smaller triangle. So this is the L0 I need to work out. This is L0 I need to work out. And we know this part is Y, right? This part is at some position Y. So what is the longer length of this purple triangle? So this part will be h minus y. So those purple triangle and the brown triangle, they are similar to each other. So you will get a similar triangle formula. H minus y over L0 will equals h over L 1/2. Then in this way, you can get the expression of L0. It's a function about y. Then you can evaluate the volume with the formula C2D AY dy. Okay, I will send you 5 minutes to finish this quiz. Okay, so I give all those hints here. Try to figure out the expression of the volume.